Hello, I'm Nino and I'm going to present our information visualization project Nutriverse. This is worked on by the students Nino Verstraeten, kobe.vanlaere and Luca Desmet. Now for our first visualization we made a Nutri-Cosmos. This is a nutrient network, which means it's a force-directed cosmic network that maps biochemical relations, which only will be used for navigation, but make exploring the nutrients a little bit more fun. The planets represent the nutrient nodes, and the moons encompassing it represent the top 10 nutrient-dense foods per planet. Now for our visualization 2, we made a meal builder. We have some demographic information such as the age, the sex, and the weight, which will be influencing our EFSA guidelines for recommended dietary intake. And based on this, we'll make a personalized visualization. The country will be used to navigate to our third visualization, which the user can explore his or her country, but later more on that. The bar charts will be showing the progress in amounts of nutrients for the intake. This proves how a meal can dynamically react to the properties of a changing human body in real time. For a third visualization, the hidden hunger, we made a chloropleth map, a line chart, a bar chart, and a scatter plot. And this will visualize the production paradox. A country might produce a lot, but still might suffer from massive deficiency rates like anemia. We also have a stunting chloropleth map. We also have the wasting chloropleth map. And the most produced foods in a country does not guarantee nutritional security. Alright, welcome to the Nutriverse. I'll have 3 visualizations to present. The first visualization is the nutrient cosmos. This is a force-directed cosmic network mapping the biochemical relations. The planets represent the nutrients, while the moons show the top 10 nutrient-dense foods. So first off, we see here we have 75 nutrients in total. On the left you can select a nutrient filter, and based on that you can search here on the different types of nutrients. When clicking on a nutrient like the retinol, which is a vitamin, we see that it has 0 links and it will show up as just one vitamin retinol with no edges. We can see the top food sources per 100 gram, which means these are the most dense in the vitamin retinol. The first one is the cod liver oil. Then we have liver, poultry cooked. Then we have pork liver, foie gras, and another liver, duck, rabbit, pate, and some other values. On the bottom right, we can explore further to our second and third visualization, but later more on that. So if we pick, for example, vitamin A, we can see it has 6 links, which may be a synergic or an antagonic relationship. We don't visualize the difference here because that is not important. We'll use this graph for navigational purposes. When hovering over a planet, we'll see that nutrient. The best source includes gut wheat. When we hover over it, it shows the moons connected to it, and these are scaled based on how much a nutrient dense it is for that nutrient. So for zinc, we can see European oyster, and if we can't really read it correctly, we can tap it again, and then zinc is in the middle to show the focus with the detailed food sources on the right. You can also hover it to see if some text is cut off to check the full name of it. You can also hide the sidebars and play the animation. Now for our second visualization, we'll build a meal with these nutrients information. So now we have the perfect plate visualization of the second. This one is a personalized dietary tracking based on your demographics. And here you can see how your meal dynamically fulfills the EFSA recommended intakes in real time. So on the top left, you will search for foods, and in here you have your meal tray, which will include all the foods you added. Then you have your profile for your demographic details, and a global context to go explore the third visualization based on the country you select here. Now we can, for example, add chicken or a Caesar salad with chicken included. You can also hover over it and it will show the full name. You can set here different amounts of grams of your portion and add it to your meal. Now if that food includes nutrients which are included in the EFSA recommended intakes, it will show a bar with how much percentage you are away of your recommended intake. Now you can see here for this one we'll have 30 under target, and if we add more foods like rice, Cantonese rice for example, we'll see that we're now for 31 under target, but we can change the portion size and influence the percentage. If you want more insight, you can click on the plus icon, which shows the top sources in the meal with the respective unit. Then if we change, for example, the age to 17, we'll see the values update and the percentages change. Same for if you are a female, then change to 23%, and if you set activity level to very high, it changed to 21% because we need more kilocalories per day if you train at an intensity of very high. Same for the other nutrients. Macronutrients are grouped here, the lipids and the fatty acids, and the vitamins, the minerals, and other nutrients. Now, if we, for example, click on copper, you can see how much each individual food contributed to the total. If you want to learn more about this mineral or the more nutrients dense foods that have copper, we can go back to the Cosmos graph, and then it will have copper selected, And you can see then the top foods that contain copper. Then if we go to the global context, which I mentioned, you can select your country and navigate to the third visualization, which is our color path map. Now visualization 3 lets you explore the global deficiencies via maps and charts. You discover the production paradox, where high food production doesn't guarantee nutritional security. Now, the first one, we have an anemia, which means a deficiency in red blood cells. This may be because of too little iron intake of certain populations. Then you can see, for example, the default is Afghanistan, but if we go to Belgium, we can check here. The current rate of anemia is 13.6%, and extreme poverty based on the World Bank source, which is $1.9 per day. The population is 0.1% in extreme poverty. The 13.6% is the same color as our legend here. It will be the same color on the chloropleth map. We can check the progress of Belgium based on the anemia percentage over time. Now I'll show the production paradox of what the country produces versus what they lack. Now, despite producing 15.5 tons of food, 13.6% still suffer from anemia, and we can see here the most produced foods of that country. You can hover over the text if it's not clearly visible, if it's cut off because the text is too long. Now, for the last one, we have the global divide, which shows the regional comparison of poverty versus anemia. We have on the left the anemia rate, and on the bottom the poverty rate. If we hover over the dots, we'll see the poverty and anemia per region. This gives you a quick glance on the insights. Now, Africa has the most percentage, but it also has the highest poverty rate. And the same logic applies to the other regions. Then you can navigate here back to the other 3 visualizations if you want. Now the same goes for stunting, which updates the chloropleth map. Belgium still is selected, and we can see the current rate for stunting is 1.6%. Stunting means there is a limit on growth per human based on a deficiency in the nutrition. And then we also have the same production paradox and an updated global divide with the stunting rate and the poverty rate. For our last one, we have the wasting, which means how much the country is wasting. For Belgium, it's 0.4%, but for example, for South Sudan, it will be 22.7% with an extreme poverty rate of 79.2%. Global divide is also updated. And with this, we have seen all our visualizations.